Good morning, students. Today we are going to see that algebra and number theory. So it is shortly called as ANT. Okay, so today we are going to see what is the content we are going to see throughout the semester. There are 5 units that was given here: groups and rings, finite fields and polynomials, and divisibility theory and canonical decomposition, and then Diophantine equations and congruences, classical theorems, and multiplicative functions. This paper is very useful for your programming, and it is very easy to learn, easy to write, everything like that. Now we'll see next topic called group. This is a basic thing for for this subject. First, you know what is a group. Generally, we can call that group is nothing but a collection of set. It is a well-defined objects or well-defined set. You can say that it is a general one. But in mathematical, you usually say that group consists of a non-empty set G together with a binary operation star such that the following properties hold. That is, a group is a non-empty set. That means there will be a values. Set means there will be some of the collections, and then together with the binary operation. Here the star binary means it is two values. So here the star is mentioned for addition and multiplication. That is plus sign comma dot sign. So both are included in this star binary operation, and it holds some that the group has to satisfy some of the axioms that are followed here. First property is the closure property, and that in the closure property, if you are taking any two values from the set of that group G, when you are undergoing an operation called addition, means when you are adding two elements from the group, you have to have the answer as some value that also should be in the same group. Then you can say that closure property is accepted. And the associative property, the second one, in this case you have to take three values from the group, and you have to undergoing addition operation means when you are adding three values you will get some answer. That answer should also be in the group G itself. If we are obtaining that one, means the second condition, associative, is also accepted. The third condition is called identity. Identity is nothing but when you are adding any number to a another number, you have to obtain the same value. If you are taking one, for example, if you are taking one in the group, means what number will be added with the one, you will get again one itself, means that is called identity. For one, I'm adding 0, I'll get 1 again. So that identity value is 0 in the group. And the last one is inverse. If I'm taking 3 as the inverse, in this case for addition, I'll have to take the value as minus 3. When you're adding these two values, get the answer as 0. So inverse of this value, I'm saying only for the binary operation addition. If you're undergoing an operation called multiplication, means you'll have some other operation, some other values, and in that case also all the four properties have to satisfy. So for a group, the four axioms are very important. The four axioms should be satisfied, then only you can able to say that it is a group G. So they have given some examples here. First one, they are given R plus 1. R plus 1, R comma plus. So R is nothing but a real number. And they undergone the value as addition here. That's why they've written like within a bracket R comma plus. And what is ID means? It is identity. Since for real numbers, you can able to have the closure property. If your closure is accepted, associative will also accept it. That's why they have not written here. They have directly gone to identity value. So identity means obviously for plus you will have the value as 0. For addition, you will have for all the number set of numbers, you will have the value as 0. And then last one is inverse. Inverse, here you will have the value as minus a. That means for a you will have minus a. That means if what number you are taking for a, that will have the value as with the minus sign as the inverse of that case. So this is for any type of real numbers with the addition symbol, with an addition symbol. This is one of the example as a group. And second one, r to the power of plus comma dot. That means r to the power plus means it is only the real numbers consist of zero, negative numbers and positive numbers, and also decimal values. Everything will be adapted in the real numbers. In this case, they have specifiedly written as r to the power of plus means you have to take only the set of positive real numbers. That is the main major thing here. But the operation is dot. That means multiplication you have to adapt here. So obviously the closure property and associative properties are acceptable. And finally you have to take identity property. In this identity property, they will have the value as 1. Identity value will be 1 in the multiplication, and the inverse is also 1 in the multiplication. So this is the second example. Third example, q comma plus. Identity will be 0 and inverse of a will be minus a. As similar in the r comma plus, here also q comma plus means q is the rational numbers comma plus. What is a rational number? The rational numbers means in a decimal value only there have some n point. After the decimal they will have some place value will be ended at some case. That is called as a rational number. So that is mentioned as q here, q comma plus. So identity is 0 here and inverse is also minus a. So as similarly r comma plus. For q comma dot, that is q comma dot means multiplication, identity will be 1 and inverse will be 1 by a. And then example for z comma dot. Z is the set of integers. It will have positive value, negative value and 0 with the multiplication. Identity will be 1 and inverse of a will be 1 by a here. This is the examples for the group. And now we'll have abelian group. So what is meant by an abelian group? Additional with the group axioms, extra another property is included, that is called commutative property. Otherwise it is a abelian property. That is a star b equal to b star a, where a and b belongs to g. That means when you are multiplying any two value whose inverse also multiple, both are equal, they are saying, that is called as an abelian group. This is abelian group. And then order of a group. Let G be a group under the operation star. The number of the elements in the G is called as the order of group, and it is denoted by order of G. It is simple. If you're having a set called S is equal to minus 1 comma 0 comma 1. How many elements are there? 3 elements are there. So the order of the group is 3. So that is what's denoted in the order of a group here, and it is denoted by O of G. This is order of G. Number then note they have given if G has n elements, you can say that order of G is equal to n elements, n. And if order of G is finite, then G is called as a finite group. If we have a finite value, there will some in some of the number system, we will have some limited values. There you can say it as a finite group. If you're having a real number as a group, then it is an infinite group, which was denoted here. And then the subgroup. A subgroup is nothing but, since we are having a group, in that group they will have some one of the mainly any of the axioms can be satisfied is called as a subgroup. So that is called the subgroup. I denoted here. If H is a non-empty subset of a group G, then H is a subgroup of G if H is a group under the same operation in G. So mainly here it is nothing but one of the set. Say since G having a collection of set is there, no, among that they will have some of the set alone. So that is called as subgroup here, and they have to satisfy the axioms as like in the group which was given here. Thank you.